One of the things that we are starting to explore more and more is the agentic AI architecture. And basically, what this is really breaking up your AI solutions into small agents or AI agents. And it's the same concept that we're used to with pro development, where you implement this separation of concern. It's really the reason why you have little modular chunks of code that when put together, they can, when composed, they generate another purpose of the code. And how you compose them or how you stitch them together is the meaning of the new solution that you create. So this is how things are going to change from our perspective as we kind of build these out moving forward. So initially, and if you know me and you follow my content, you know for a fact I'm a very, very, very strong component with building business applications on the Power Platform within the Microsoft 365 ecosystem. I'm not necessarily talking about co-pilots because the solutions that we build, we have more control over the calls of the AI, the parameters that we send, stitching together what Copilot calls like AI flows. And it's just say, hey, this is an agent. And once that one complete, call this agent, take the output of that, call this agent, and so on and so forth. So we have way more control over our solutions, and especially with the call to the LLM. So we want control over the top P. We want control over the tokens that are being used. We want to control over which prompts are being used at what point in time, the sequence things are done, if it's in parallel, if it's sequential, or whatever the case may be. So when building our apps, let's just take this proposal generator. So we have an AI proposal generator that we use for RFPs or RFIs or RFQs. And in this proposal generator, what it is that the user has an input, and we actually have them copy and paste the request into this text box. And then what they would do is click on the button. When you click on that button, and that's like this is a Power App. When they click on the button in the Power App, what we tend to do, and again, these are reusable patterns that we have built, and it allows us to create these things in a fraction of the time. We usually save all of that input into a SharePoint list. And once the data is stored in the SharePoint list, so just say, for example, it creates like a key for that record. This is the information that was in this text box stored in this column. This would then trigger a Power Automate. And the way that this Power Automate works is it's set up with a trigger where a new item is created. So that way it's only triggered once, and we have control over that because we do update statuses and all this other good stuff. So we don't want this thing to be kept being triggered like almost like in a loop. So it triggers this Power Automate. Let's just go ahead and label these. So this is SP list. I'm going to just name this P Auto for Power Automate. And from here, the first thing it does is based on this Power Automate, it calls the prompt. So there's a subflow that's in charge of all of our prompts. And all these subflows that we create, like in this sequential AI solution, and when we kind of fan this out to be more of an agentic AI solution, all of our subflows would then kind of turn into agents. So this would be a great component. This subflow for prompts would be great component for a prompt agent in that regard. So it calls the agent. We don't use like the Power Platform or the Azure prompt catalog. We create our own. Most of that is because to use the prompt catalog that's in Azure, it's actually a premium feature once you tie that into your Power App. And we don't want, just to, unless there's a strong use case of why our solutions need to be a premium solution, we tend to try to stay in the standard realm of things. And if we have to create something manually and build services around that, we will do that. And plus, we want more control over this. So being a SharePoint list, this prompt catalog is actually two-dimensional. What do I mean by that? One, the application itself is identified with a key, and then it's set up to where each application can actually have subprompts within it. And actually, we didn't know when we were setting up this architecture in this way, but we didn't know that this actually primes us to use an agentic architecture. And the reason for that is that with an agentic architecture, each AI agency actually has its own prompt, because a prompt defines you're concerned with this piece. You're responsible for this domain of data, and these are the functions that's needed to interact with this domain of data. And then you define what the signatures are for a caller to call you as an agent. And you also agree on the response or the output of how you will return the output of that data as an agent. And again, once I describe that, for those who are developers and have developer history, like, oh, that's nothing but more than a function. All right, oh, that's nothing more than just a microservices. Or, oh, that's nothing more than just a subclass or a service within the application. That's exactly what these AI agents are. But, they have their own smartness, and their smartness is this, they're the SME or the specialist for their part of the domain. So we'll talk about how that works. But anyway, so this sequential architecture here, it goes and get the prompt. Based on the key that's passed, it returns the prompt back to the caller, and then that prompt provides it to another process within this application Power Automate flow, and it builds like the message array, which we know is like the key component when calling the LLM, especially the OpenAI LLM. So we define like what our system is, what the user is asking for. If we want to give it examples, we may do a combination of user agent or assistant, user assistant, user assistant, user assistant, and then the new user question that we want to pass, and then the LLM will respond back. The issue that we run into with the singularity type AI solution is that our prompts are extremely meaty, right? So what do I mean by that? To better explain that, this document here, let's just say this is what a proposal look like. In that proposal, we have a cover letter. We have an executive summary. Then we have these subsections that answer the requests on a very detailed, very specific nature. And in these subsections, we also may have like capability statements, history of our ability, and why we as an agent or a consultant firm, why are we the best pick for this job? And then there's like a conclusion. In the conclusion, I'm actually do this one in magenta, right? So each one of these proposals really kind of have these segments, these different areas or sections, key sections of it. And then these sections here, this could be one, minimum usually 3. So this could be 3 or 20, right? It could be 3 or N. And what we have to do is the prompt that's receiving this request would determine how many subsections are needed to respond back to that proposal as a proposal, right? So in the one prompt, we have everything defined, like what the cover letter should be, what the executive summary should be. And then there's a prompt that determines all the subsections are needed. And then it defines, okay, this is what you need for section 1. This is what you need for section 2. And when I say sections, it is things like, this is the description of the solution. These are the security measures and regulatory things that need to be considered. This is an example of the solution from an architect approach, a technology approach, technology profile. Whether it's the project cycle, meaning that there's requirements gathering, then there's implementation, then there's Q&A, and then there's cycles of Q&A, then there's user acceptance testing. So you kind of go through that project cycle with them, and then you define all this other stuff. Like that's the meat, that's the core ingredient of a proposal. The issue is in our message array that we send to the LLM, so let's just say like this is where that message array is being created. We stuff all of this into it. And prior to it's a little bit better now because GPT, the latest version of GPT 4.0 or 4 Omni allows you 16,000 tokens in the output window. So that gives you 4x the amount of room you used to have with the previous version of 4 Omni. And now, the LLM, even with a zero shot a request can return a decent document, but it may not have the level of detail needed if we were doing this by hand. So what we found was the document return is decent, but a human would have to go in to fill in a lot of gaps and add more clarity to these sections, add more meat to these sections, more context to these sections, because we felt like the LLM was doing everything in its power to stay within that token window. So it abbreviated a lot or summarized a lot versus going into the verbose detail that the client or the requester would appreciate if we had that more level of detail. So this is how we will change that model. In the agentic architecture, it looks something like this. We still would have the Power App to collect the data. We still would have that input window to where they would add information and they would click the button. We still would have that data stored inside of a SharePoint list. We still would have that new entry in the SharePoint list fire off the Power Automate. But this is where the change happens. It actually happens in the Power Automate. So from that Power Automate, it would trigger, it would get a prompt, and the prompt that it gets is only one prompt from the prompt catalog, aka our prompt SharePoint list. And really, that's the prompt, that's the controller. Like, this is the captain of the application. And what the captain would do, and this would kind of be like the captain agent. Really, if this would be like the main agent. Back to pro development. So you remember, like, when you're building like your set of classes, or even if you had like a console app or a batch job, you had that one class that was like the main thing that would determine everything else that would happen. It's the first entity, module, section, service that's called, and in that piece will define everything. That's exactly what this agent is. And normally, from a naming convention, this agent will be called whatever this application or solution is called, right? So let's just say this is going to be an AI proposal generator or something like that. Right. So this would probably be the AI proposal agent or the proposal agent. OK, so it's this proposal agent that determines everything else. This proposal agent knows it needs to call another agent. And I'm going to go down here for more room for the cover letter. So this will be our cover letter agent. And I'm going to abbreviate AGT for agent, right? So this is going to be our cover letter agent. The cover letter agent, when it's called, it would then go to the catalog for the application. Again, it would have two parameters for that prompt catalog. It would have the application key, and then the sub key or the sub parameter would be cover letter. And that's how it knows from the catalog which prompt is needed for the cover letter. So then that will return. And this would then do its thing. It will take that prompt. It will have the input from the original ask, like from the proposal agent, this main agent here. It will pass it that says, oh, we're generating a proposal. Here's the user text for this particular proposal instance. It will pass it to it. And really, that's all it needs. The body of this knows how to get the prompt, handle the prompt, handle the user task, create that message array, call the LLM, process the results of the LLM, and then return that back to the main agent service, right? Again, then this proposal agent, and it may not do this in sequence. I'm just building this out, explaining this in the sequential manner, but understand most of this will happen in parallel. That's the magic behind it, because it's a fire. Is it a fire and forget? Yeah, it's a fire and forget, and then it will prompt something when the response is ready. So it's not gonna wait on these agents to respond in order to call other agents, unless it's calling an agent that needs the output of the previous agent as an input for that agent in order for it to do its work, right? So here in this scenario, it's going to call the executive summary agent. Then it will call and then it does something interesting here. So let me pause here for executive summary agent, right? So here it calls the executive summary agent. And then the other thing that this proposal agent may do, it may call and I'm making this up, right? As I'm thinking of this, I'm thinking like real time, I'm designing this, I'm architecting this in my brain, but this is nothing new. Like doing the separation of concerns, encapsulating heavy lifts, hiding the way the sausage is made, and just spitting out sausage patties. We're used to this as architects. It's just a matter of how you do this in the AI world, and back into this now fancy name of agentic AI architecture. But it's the same design principles that we're used to with designing classic applications. So here, in my mind, real quick, I just thought of this. It's going to call this other agent. This agent is going to be the section manager agent. What do I mean by that? This section manager, again, remember how I said that these proposals we went through the anatomy of the proposal, right? We went through the anatomy. So this is a cover letter, this is executive, but this could be 1 to n number of subsections. This is what that manager is going to do. So based on the proposal request from the user, for this particular instance, this manager would determine how many sections, the title of the sections, the definition of the sections this proposal needs to respond with. So this is actually going to create an array of sections needed to respond to that RFP accordingly. And the output of this, and now this is where I'm struggling because, I'm going to keep this in the color flow because I'm struggling that, okay, if this creates a subsection, does it do the calling of the sub agents inside of the section manager, or is it sole responsibility is to return the JSON object of all the sections needed? Let's say the JSON object of all the sections needed, right? So here, this is going to be an array, a JSON array, and inside of that, it's going to have the section, the definition, the title for each one of these. And this could be 1 to n number of sections needed. And then from there, we're going to do a loop. And this is in Power Automate terms, this is going to be apply each. We're going to do this loop. And in this loop, it's going to call the agent that builds sections out. And this agent is going to expect these objects to fit within the parameters that it expects, and it knows how to build sections out, right? And it knows the guidelines of what's needed for each section, right? So this becomes very, very interesting. And because you remember, like, we try to do as much as we can in parallel, right? We want to keep our threads busy. That's one of the things that you learn in object-oriented architecture, and then really just try to optimize the infrastructure when it were possible. You always want to keep your threads busy. So we do more asynchronous parallel type calls than sequential, single-threaded type calls, just so that we can get a unit of work done as fast as possible, right? So that's what we're going to do with this apply each. Like, even though it's looping through a collection, we're going to set the settings of parallelism. We're going to set the setting of how many we want to have done in parallel, and then we're just going to allow it to do its thing out of the box. So if this has 5 sections, this will be configured to process all 5 in parallel. And the way it does that is that they will be triggered in a sequence, but it's not going to wait for the first one to be done in order to call the second one. That's what parallelism, if that's turned off, that's what happens. And that's the default setting. So we're going to go beyond the default, turn on parallelism, and basically in that collection, what it's going to do is loop through and fire, and then wait for everyone to get completed, and then process the output as a whole, right? So that's what's going to happen there. So that's going to be that piece. And then lastly, what we're going to do, we're going to call our conclusion agent, which is here. And this is the one that's going to close the show with our conclusion. Now, once all of that's done and all these calls are made, let me just draw this fictitious line here. This is everybody processing. Then you almost have an output agent, which is going to be treated like a catch-all bucket, right? And basically what it's going to do is going to wait for all these agents to get done. It's going to wait for all these agents to complete and collect all of their outputs and formulate the final product. And as you can guess, these may all end at different times. So what it's going to do is going to sit there and wait for everybody to complete, even this apply each, where you got parallelism happening, 1 to n number of sections being processed. It's going to wait until all these are done. It's responsible for putting together the final product. So it will also go to the prompt catalog, get its instructions, and know how to handle all of these inputs, and then create the final output. Now, this is where the magic happens. This final output from the prompt could be JSON, meaning it's structured, HTML, meaning that it's going to take all the documents and create one beautiful HTML file, and then from that file, you can do what you will as a caller to the service. Or, what I love, PDF. Right? And this is where you can do some very, very interesting things. Now, actually, it's not going to be PDF. That's a separate agent. It's just going to be text. Because really what this is going to do is going to take all those input. It's a whole responsibility as an output agent. Take all the inputs, put them in the right order, right? Make sure it's cover letter, executive summary, your suite of sections to make your case, and then a conclusion. Right? That's the order. It's going to ensure that all these are in. And it's going to, if it's JSON, it's going to put them all in the right slots in the JSON schema. If it's HTML, it's going to put them all in the right slots and make sure headers have the H3 tags. The bodies are wrapped with div tags and paragraphs, things that need to be highlighted or bulleted lists or points or unordered lists and all. Like, it's going to do all that magic. And there's no processing to do that. That's all done in the prompt. What that looks like, what that snippet looks like is all defined in the prompt. The AI does all the heavy lift with returning that HTML to make sure it looks like that, okay? And then if you wanted to, this is where I would say grow into a phase 2. If you wanted to, this is where you would have a documenting agent. In this documenting agent, this is the one that would take the output from here and generate a Word document or generate a PDF. And usually if it's a PDF, it starts with Word and then we convert that to PDF. The benefit of the documenting agent, and again, this could be a heavy lift depending on how fancy or how crazy you get with it. But in my mind, just, off the top of my head with solutioning this, I would start with like a Word template. And that's branded, so it will have the consulting company's logo. The headers and the footers will be well defined. It will be parameters on like stating like the project name or the name of the thing that it's responding to as a proposal. The different sections will be formatted as such. So the cover letter will be really nice. It will be segmented into its own page. It will have a page break. It will start off with executive summary. That will have a certain font type, size, and font family. And then I will get into the sections, and that will will follow a well-defined formatted set. Right, so each section header will have a certain header type, certain style, font family, size, bold to make it pop. Then you would have subsections within the section, and each title of the subsection will have its own treatment. The body will have its treatment. Ordered list, unordered list, bullet list, all this stuff will have its own treatment, the right indentation, and then it would just crank to spit out as many sections as needed. And then you would get into the conclusion or the final output of it. That usually will start on its own separate page to make it pop with the right title and then a nice description format for the conclusion, right? And then it probably would end with standard contact information and all this other fun stuff. That would be a template, and that's what the documenting agent would do. Like, its whole responsibility is taking in this text input, merging it with that template, and making sure it's slotting all the information in the right slots, right? And once you have that, now you return the final product to the caller, and that could be in the form of dropping that file in the document library, sending the email notification that is done, and then the link to the document as it lives in the document library. This, my friend, is the magic behind agentic AI architecture. Now, it may seem like a lot of work, but I promise you this. The work is actually offloaded to the LLM. Each one of these agents, let's just zoom in real tight here and talk about what does an agent look like. Each agent will have an input. We define that, right? And then it will have, let's just say this box is the agent itself. The second thing it would do, like once it has this input, it would go and get the prompt, right? Once it has the response to the prompt, that input is actually the user text stating that for this proposal, this is the request. And that's what that's a transaction. So it would pass in that information. The prompt tells it like, you're this type of agent. This is what I expect of you. And then it creates that message array, which is real standard. We should be super used to creating these array, super used to defining system, user, assistant, and making sure they are in the right sequence. If you have to have examples, you got user assistant, user assistant, user assistant, then user, and then you pass that to the LLM, and then it gives you the assistant for this particular call. The benefit of this, so once you get that LLM back, it knows how to process the JSON. Again, the prompt tells it what that JSON would look like, if it should expect a single file, or not a single file, but a single text blurb with the HTML, or should it expect a JSON with a certain schema? Should it expect just plain text with maybe markup to help define the prompt would tell it what to expect. So here in the agent, we're going to process that output as such and then pass that back to the caller. This is the anatomy of the agent in general. Now, we can take this to another level, especially when we start dealing with other domains that are in data that is interfaced with a different platform. So, for example, what I mean by that, what if this was an agent for ServiceNow? Calling the LLM and all this other good stuff with ServiceNow is one thing, but the question, the parameter that comes in, again, this is just text. The parameter that comes in may say, I'm looking for clients that are in this demographic, that have this number of sales, and has an activity date no later than this date. All of that is a paragraph within the text. To make that happen, it knows what it can and cannot do with ServiceNow, or even Salesforce, or even SharePoint, or even SAP, or Dynamics 365, whatever it is, it knows how to interact with that. But it also may have functions that are defined to the AI that the AI determines based on this Salesforce data, I need to call this function. Once I get that output, call this function. Once I get that output, call this function. So these agents is more than just prompts in LLM. These agents are actually now functions and prompts in LLM. And then it gets even crazier, because now you may have a agent for Salesforce that is just a controlling agent, like everyone calls the controller. It determines what functions to call. It also determines which other agents to call within this domain. And then that's when your neural net starts to grow and span like crazy, because now you have agents with their own network of agents that have their own network of agents that have their network of agents. And then you got 7, 8, 9 degree of agents networking per call. Crazy, 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 crazy stuff, right? For now, for this phase, we're going to keep it simple. But this is the idea on how you create this agentic AI architecture. In the next set of videos, I'm not sure how many videos it's going to take, but the next set of videos, we're going to tackle this and build this within the Power Platform. Let's get to work.